Hunting for water in the inner solar system. Part 3. Mars. Mars, at its closest approach to Earth on October the 20th, 2020, at that time the distance between the two planets was 38,600,000 miles. And this image was made by shooting the camera in movie mode to create an MOV file. It contains about 3,500 individual images. These were then stacked together in a free program called PIP and processed in Adobe Photoshop. Here is the layout of close approach. Distances in the solar system are enormous, so they're measured in astronomical units, abbreviated to AU. The distance between the Sun and the Earth is 1 AU. The distance between the Sun and Mars is 1.5 AU, half again as far. Mars is about half the size of Earth, but only 1/10 of its mass. As the solar system formed, Mars cooled much faster than Earth because of its small size and mass and its great distance from the Sun. For a planet to have a magnetic field, it must have a liquid conducting core and rapid rotation. Earth has this, a liquid conducting core and rapid rotation. Venus, on the other hand, has a liquid conducting core, but only slow rotation, while Mars has a solid core, but rapid rotation, which means that of these three planets, only Earth has a magnetic field. Mars had a magnetic field in ancient times. As it cooled, its liquid conducting core solidified and its magnetic field was lost. When it lost its magnetic field, it lost most of its atmosphere to the solar wind. Without a protecting atmosphere, it lost much of its surface water. Time brings change. Why do we think Mars once had a magnetic field? Well, the older rocks contain iron particles that cooled lined up north to south, indicating this field. The later younger rocks do not have this field recorded in them. The surface of Mars is filled with interesting features left behind from long ago when Mars was more temperate, had a magnetic field to protect it, and had water and greater atmosphere. These features are much older than Earth's ever-changing features. The surface of Mars is crossed with dry river valleys, rocks and features that only form in water, deep water, shallow water, rushing and still water, salty and fresh, all part of an intriguing past. That water once flowed on Mars is certain. The water on Mars left grand evidence, dried up deltas like this one, riverbeds, empty waterfalls, barren lakes. Mars, like Earth, has details of water evidence as well, such as rounded pebbles, rocks that bumped their way down streams until they became smooth and round, and then stopped in depressions or ancient pools. The rock record pictured by the spacecraft Mars Express shows that rock and soil was carried by flowing water. There had to be rain on Mars long ago to build these features. Rain from clouds in a regular water cycle went on for, well, a long time, about 3.8 billion years. There must have been a lot more water than there is now on Mars, because of the many grand watercourse features that we see today. And if there was rain, then there must have been atmosphere. enough atmosphere to hold that rain. Mars has no liquid surface water today. The thin remaining atmosphere is not stable enough for liquid water to be present. This is Mars' North Pole from above. Thick water ice is confirmed at the poles of Mars, and there is a good probability that liquid water lakes lie protected under the ice as they do under the polar ice of Earth. So what was once a water world is now a desert world with only a hint of liquid water. This series of images shows warm season features that might be evidence of salty liquid water active on Mars today. So the inner solar system has evidence of water everywhere. There's Mercury with probable water ice, Venus with possible ancient seas, and of course our Earth with abundant water, liquid, solid and gas, and our Moon, our stabilizing companion, with molecules of water across its surface, and finally Mars with ice and strong evidence of abundant water from the distant past.